There are a lot of shapes on the SAT, and while we've gone over rectangular solids, there's a special type of rectangular solid that we're going to take a closer look at: the cube. Almost everything about cubes can be broken down into 3 equations. In this lesson, we'll go over solving for the volume, surface area, and the long diagonal of a cube. A cube is a rectangular solid with all equal edges. Because all the sides are squares, we know that all the sides of a cube are equal. The first equation we need to know is the equation for volume, which is volume equals side cubed. The second equation is for the surface area. Surface area equals 6 times side squared. We'll cover the third equation later in this lesson, but for now, let's focus on an example that calls for the 2 formulas we just learned. What is the volume of a cube if its surface area is 1,014 centimeters squared? Since we're asked to find the volume, we need to know what the side length of the cube is first. To do that, we need to remember that the surface area is 6 times side squared, and we're told that the surface area is 1,014. Substituting the value we're given for surface area, we can drop the unit of measurement as we solve, so we get that 1,014 is equal to 6 times side squared. Dividing both sides by 6, we get that 169 is equal to the length of one side squared. So if we take the square root of both sides, we get that a single side of our cube is 13 centimeters long. Now we just need to use the length of a side to find the volume of the cube. Since volume is equal to side cubed, we can set up our equation as volume equals 13 cubed. If we plug this into our calculator, we get that the volume of this cube is 2,197 centimeters. Go ahead and bubble this into the grid provided, and move on to the next question. As we've seen, these formulas are pretty straightforward, and the ability to use the surface area to find the volume is definitely a handy tool. Now let's take a minute to look at the equation for the long diagonal. The long diagonal is just the length of the longest line that can be drawn connecting 2 vertices of a cube. So this line from vertex A to vertex D is the long diagonal. Fortunately, there's a simple formula for the long diagonal of a cube. The length of the long diagonal is equal to the value of the side length times the square root of 3. Let's look at an example. The volume of the cube below is 125 cubic inches. What is the length of AF in inches? Here are your answer choices. Since the formula for the long diagonal is long diagonal equals side length times the square root of 3, we need to find the length of our side first. To find the side length from the volume, let's consider our volume equation. Volume equals side cubed. We're told that the volume is 125, so we want to set that equal to side cubed. To solve for a single side, we take the cube root of both sides. To plug this into our calculator, we would type in 125 to the 1/3 power. Don't forget your parentheses. This gives us an answer of 5, so the length of one side is equal to 5. Now we can plug 5 into our long diagonal formula. So we have long diagonal is equal to 5 times the square root of 3. We don't need to plug this into the calculator since 5 times the square root of 3 is answer choice B. Circle answer choice B. Okay, enough of cubes. Let's treat ourselves to one of my favorite shapes, the sphere. To recap, everything you need to know about cubes on the SAT comes down to these 3 formulas: volume, long diagonal, and surface area. Get to practicing these formulas so that you can pick out these types of questions quickly on the SAT, and you'll be in great shape.